Okay, so let's continue the part 2 of this series. Now, observe this problem. Okay, this is a very different kind of problem because there is no complex number involved in the question. All the terms are trigonometric. All the terms are trigonometric, but yet we can solve this with the help of complex number. Okay, so this is actually a very general problem in complex number, which is discussed by most of the teachers. But to understand this, you need to solve this very carefully because the variation of these kinds of problems are very good. So I'll not be surprised if a very good problem comes from this category. Okay, so let's start the problem. So there are two relations which is given to us: sine alpha 2 sine beta 3 sine gamma, cos gamma 2 cos beta. Okay, modify this should not be gamma, this should be alpha. Cos alpha plus 2 cos beta plus 3 cos gamma equals to 0. Okay, so to solve this kinds of problem, what do? We consider a complex number which has the argument alpha, beta, and gamma. So first complex number that I'm going to consider as Z1 as e power I alpha, and second complex number I'm going to consider as e power I beta, and third complex number that I'm going to consider e power I gamma. And let's write it in terms of the polar form also: cos alpha plus I sin alpha, because we need to convert them into anyway in the trigonometric form: cos beta plus I sin beta, and then z3 will become cos gamma plus I sin gamma. So anywhere Z1, Z2, Z3 I'll be using, I can convert them in the Euler form as well as polar form at any point. Okay, now let's observe this. You have cos 3 alpha. I'm trying to solve the first part. So you have cos 3 alpha, cos 3 beta, cos 3 gamma. So somehow you need to bring in the picture Z1, Z2, Z3 whole cube. Z1, Z2, Z3 whole cube, so that this alpha will become 3 alpha, 3 beta, and 3 gamma. So for that, I'm going to use the given information. This is very critical information. So observe this: alpha's coefficients are 1, beta's coefficients are 2, and gamma's coefficients are 3. So accordingly, I'm going to consider a term which is Z1 plus 2Z2 plus 3Z3. So observe this term very carefully: Z1 plus 2Z2 plus 3Z3. So anyway, it's going to be a complex number, so I'm going to rewrite it as separated real part and imaginary part. So what do we have? What will become cos alpha? See, observe this: first term will become cos alpha, and the real part of the second term will become 2 times of cos beta, and the third term will be 3 times of cos gamma. So real part of this LHS will be this cos alpha, 2 cos beta, 3 cos gamma. Now imaginary part is also I'm writing I times of sine alpha plus 2 times of sine beta plus 3 times of sine gamma. So observe this: actually both the terms are given to us 0. This term is also 0 as well as this term is also 0. So this will be equals to 0. So now you have something like, if I consider this term as A, if I consider this term as B, if I consider this term as C, so you have what? A plus B plus C equals to 0. You have what? A plus B equals to 0. In ninth class, you must have studied the identity. If A plus B plus C equals to 0, so either A equals to B equals to C. Anyway, A equals to B equals to C need not be correct here, but one of the other identity which satisfies, which is A cube plus B cube plus C cube equals to 3ABC. If you have A plus B plus C equals to 0, it also implies A cube plus B cube plus C cube equals to 3ABC. So let's try to now solve this and try to get the relation which has been asked. So I'm considering the term A cube plus B cube, A cube plus B cube plus C cube. So observe this, what this will become. So A is your Z1, right? So this will become Z1 cube. B is your 2Z2. Observe this carefully. So this will become 8Z2 cube. And the third one will become 27Z3 cube. See, the coefficients are 8 and 27 and 1. We have got that. Okay, so now what will be Z1 cube? If you have Z1 as e power I alpha, so you will have, I'm writing it here, Z1 cube will be e power I 3 alpha, e power I 3 alpha, and e power I 3 alpha in the polar form, you can write it as cos alpha plus I sin 3 alpha. So with the help of this, we can rewrite Z1 cube, Z2 cube, Z3 cube in the argument as 3 alpha, 3 beta, and 3 gamma. So I'm writing it as, and I'm separating it again in the real form as well as imaginary form. So what do we have? If I write Z1 cube, so you will have cos 3 alpha as the real part. Similarly, if you write the z2 cube, you will have 8 times of cos 3 beta. Observe this very carefully. And the third term will be 27 times of cos 3 gamma. 27 times of cos 3 gamma. Our term is here. Observe this very carefully. But other terms also we need to consider. You will have I times of, and this will be sine 3 alpha plus 8 times of sine 3 beta plus 27 times of sine 3 gamma. So this is the real part and this is the imaginary part. One more term I'm going to consider from the RHS, which is 3ABC. So this will become what? 3 times of what? And Z1, 2Z2 and 3Z3. So 3 into 2 into 3, you will have 18, and Z1, Z2, Z3, if you multiply, what is going to happen? That all the arguments are going to get added. So you will have what? 18 times of, now convert this into real part as well as imaginary part. So you will have real part as cos alpha plus the beta plus gamma plus again 18 times of I sine alpha plus beta plus gamma. So if you compare this term is equals to this term, these two terms should be equal and these two terms should be equal. So he has asked only the real parts. What we will have, we can compare these two and write it as cos 3 alpha plus cos 3 beta plus cos 3 gamma, and this should give me value as cos 18 times of cos alpha plus beta plus gamma. So this should be our answer. And generally, actually, if this type of problem comes now, so what do they give? They give the angles as the angles of the triangle. You must have solved these kinds of problem. If you have solved this problem, then generally these angles comes as the a sum angles of the triangle. So in that case, you can use the value alpha plus beta plus gamma as 180 degree or pi. Okay, so now let's move to the second part of this problem. Second part of this problem is actually interesting. So what he's asking, he's asking to solve us value of sine beta plus gamma, 2 sine alpha plus gamma, and 3 sine alpha plus beta. Okay, so now he is asking the product of two complex number at a time. If you observe this very carefully, okay, so to solve this problem, what I'm going to do, I'm going to use the fact that modulus of Z1 is equals to modulus of Z2 is equals to modulus of Z3. So we have taken Z1, Z2, Z3 as e power I alpha, and we very well know that its modulus is always equals to 1. So what this will give us? This will give us equals to 1. So this is the fact which is being going to be used. So now if I square all the three terms, you have the modulus of z1 square. So you must remember a very basic complex number property. Modulus of z1 square anytime can be replaced as z1 conjugate. So, and this also can be replaced as z2 conjugate. This can be replaced at z3 conjugate equals to 1. So we have proved that I'm going to use this in the condition which we have proved. We have proved that z1 plus 2z2 plus 3z3 equals to 0. This we have proved. Okay, so with the help of this I can use what? Z1 as 1 by z1 conjugate plus 2 by z2 conjugate plus 3 by Z3 conjugate. So all these three terms have the conjugate. So you should not be surprised if I write all the three terms as what? Z1 conjugate, Z2, Z3 conjugate. If I write all the three terms as 1 by Z1 plus 2 by Z2 plus 3 by Z3 whole conjugate equals to 0. This is the basic conjugate property in the previous problems also I have used. So now if I simplify conjugate, if a conjugate complex number is 0, the original complex number also should be 0. From there you should get 1 by z1, 2 by z2, 3 by z3 equals to 0. So if you take the LCM, you should get the required term which you want. So LCM will give you z2, z3, 2 z1, z3 plus 3 times of z1, z2, and its value should be equals to 0. So let's see if I multiply z2 and z3. If I multiply Z2 and Z3, so check the complex number. Z2 is what given to you. Z2 is e power I beta and Z3 is e power I gamma. So if you multiply these two, you are going to get e power I beta plus gamma. Power is going to get added, and the second term you will have e power I, similarly what? Alpha plus gamma, and third term you will have 3 times of e power I alpha plus beta. So you can rewrite it in the form of, in the polar form, and your answer will be there. So its value is equals to 0. So what if you simplify this in the polar form, what you will have? Cos beta plus gamma plus I sine beta plus gamma. Second term will be what? 2 times of cos alpha plus gamma plus 2I sine alpha plus gamma, and the third term will be 3 times of cos alpha plus beta, and the imaginary part will be 3 times of I sine alpha plus beta. And see, all these terms are equals to 0. So exactly what is the term that has been asked? If you observe this carefully, this is the term that has been asked, and there is no imaginary part. There is no imaginary part, so you will have sine beta plus gamma plus 2 sine alpha plus gamma plus 3 sine alpha plus beta equals to 0. 3 sine alpha plus beta equals to 0. So the answer of the second part should be equals to 0. So see, if you solve this problem, if you solve alone this one problem, you're gonna get how many concepts clear? Observe this carefully. You're gonna get cleared your Euler form. Observe this. This, if you know this, you're gonna get Euler form cleared. You can get revise this identity, and most importantly, the trick of using the unity complex number as the product of the complex number as it conjugate. So if you solve this problem, these three concepts will be cleared. Okay, so I hope you understood the problem. Let's proceed to the next problem. Okay, so please try this problem and come back for the solution. Okay, this is a very interesting problem. Okay, let's proceed. Now, what do we have here? Observe this. See, this question is in two parts actually. See, there are two summations given. One summation is there as Q is varying, and one is when P is varying. So see, this summation is inside of this summation. So first we need to solve this summation. So what I'm going to do, I'm going to take this bracket term first, which is what? A sine of 2q pi by 11, sine of 2q pi by 11 minus I cos of 2 cube pi by 11. So I'm going to consider this term. So this term should look familiar to you if you have studied one concept, nth root of unity. Nth root of unity, because this is a slight modification of that. So to make it exactly one of the nth root of unity, I'm going to multiply by I and divide by I. So when you do that, what will happen? When you multiply this I with this I, you will have I square minus 1 will become plus. So you will have what? Cos of, observe this carefully, cos of 2 cube pi by 11, and you will have plus I. When you multiply with the sine term, you will have I times of sine 2 cube pi by 11, and you very well know that this can be rewritten as e power I 2 pi by 11 multiplied by q. And if you remember, this is the, if I consider alpha as e power I 2 pi by 11, this is the 11th root of a unity, 11th root of unity. So that you can rewrite this as alpha power q, alpha power q. So now I'm going to simplify this summations. You observe this, and you put this summation, you will have q equals to 1 till 10, and you will have alpha power q. To substitute all the terms, you will have alpha plus alpha square till what? Till where? Alpha power 10. So you know that very well. If you have the nth root of unity or 11th root of unity, you will have sum of all the roots as equals to what? Sum is equals to 0. But mind it, these all values, this all values are given, he has asked, and this value should be equals to what? Minus 1. This value is equals to what? Minus 1. So mind it, you multiplied with I, right? So here you should divide by I, and when you divide this by I, so you will have 1 by I, you will have also here 1 by I, and here also you should have I. Here when I divide by I, here also we will get minus 1 by I, and minus 1 by I, again you can multiplied with I and divide by I, and you should get value as I. It means that this whole quantity, which looks very complex, will get simplified to I. So no problem. Shifts to the second part, which is the summation of 3p plus 2, summation of 3p plus 2, where p varies from 1 to 32, and there is a constant term which is going to get multiplied with which multiplied with I. So observe this, okay, the term which we have simplified, right? The term that we have simplified, actually it has the power p. It has the power p. So this whole quantity will also have the power p. Whole quantity will also have the power p. Okay, so you'll have I power p 3p plus 2. So again I'm going to break, as we did in the second problem, in the two parts. Okay, the first part will be summation of 3p I to the power p, and p equals to 1 to 32, and the second one will be 2 times of I to the power p, again summation from p equals to 1 to 32. Okay, so let's solve this into two parts. So first part, I'm going to solve this, which looks relatively simple, which is only I to the power p. So when you expand this summation to I to the power p, p equals to 1 to 32. So observe this, what you're gonna get. What you're gonna get. 2 will be common. Okay. So first term will be I, second will be I square, third will be I cube, and fourth will be I to the power 4. Okay, so I'm going to observe this very carefully. Only these four terms, and remaining you can understand. See, I is I, but I cube is minus I, so they both will get cancelled. I square is minus 1, I to the power 4 is 1, so they are also going to get cancelled. As we know that the repetitive behavior of I, the next four terms also will be 0. Next four terms also will be 0. You can see that it is going till the power of 32, so all the terms anyway is going to get converted to 0. So actually this term 2I to the power pi p is value is equals to 0. Its value is equals to 0. So now let's come back to the second part, which needs to be calculated. Okay. So second part is summation of p equals to 1 to 32. You will have 3 as constant and p I to the power p. So now see, what do we have here? Okay, so when you put the values of I, what values you will get? See, first term you will have, when you put p equals to 1, you will have 1 into I. Second term you will have 2 into I square. Third term you will have 3 into I cube, 4 into I to the power 4. So I'm going to write 4 terms at a time, because I power gets repeated after every 4 cycles. Okay, so next term will be 5 into I. Next term will be 6 into I square. Next term will be 7 I cube, and the last term will be 8 I to the power 4. So what you can do, this is gonna go, see, this was I to the power 5. So this will go till where? Till where? 29 I to the power 29. This will be what? 30 I to the power 30 I to the power 30, and this will be 31 I to the power 31, and the last one will be 32 I to the power 32 I to the power 32. So okay, observe this I square is actually I power 6, I power 7, and this will be I power 8. So the next step, you add these very carefully. When you add these, see, all these terms will be basically what? I. Okay, so I will be common. You will have 1 plus 5 and so on till where? 29. Okay, the next term will be, see, I square, I power 6, they all are minus 1. So next term will be 2 plus 6 and so on. This will be what? 30. The next term will be I cube will be minus I, and the coefficients will be 3 plus 7 till where? Till where? 31. And the last term for all the series will be what? You will have nothing, only one common will be there, only one will be the coefficient, and the terms will be 4 plus 8. See, if you simplify this, you see there are 4 arithmetic progression, but actually you don't have to solve the 4 arithmetic progression. You don't have to solve the 4 arithmetic progression. What you will have here, what you will have, see, and the real part is what? 4 minus 2, 8 minus 6, 32 minus 30. So basically each term when it gets subtracted will lead you to only 2. And there are how many terms? There are how many terms which are there? There are how many terms? 16 terms. There are how many terms? 16 terms. So basically what you will get, no, not 16 terms exactly. So you will have 8 terms you have. 8 terms you have, and each term is going to give you 2. So you will have 2 into 8 as the real part. 2 into 8 as the real part. So exactly same thing is happening with what? The imaginary parts. But in the negative values are higher. So the negative one will, you will have 2 into 8 negative I. But mind it, all the terms are multiplied with the constant 3. All the terms multiplied with the constant 3. So when you simplify this, you will get 48 minus 48I. So see the question that has been asked. He has asked what? The sum of real and imaginary part of the term. So real part is what? 48. Real part is 48 and imaginary part is minus 48. So when you add these two, you should get 0. You should get 0. Okay, let's hope you understood the problem. Again, the same concept we have used. One which is the nth root of unity, and second is the repetition power of I, or the higher power of I. Okay, let's move to the next problem. Okay, I guess this is a very usual problem. So this is a very famous problem which comes in many test series, as well as like JEE mains also directly and indirectly they ask about this. So it's mandatory to discuss this kind of problem. So focus this. I hope most of you have got the problem. Okay. So now see. So what is asking that you have a circle. I have drawn the real axis and imaginary axis, and the circle I have already done whose equation is given to us. Okay. So let's see what is the equation. This is the equation of a circle whose center is 0 comma 25, 0 comma 25. So let me give a name to this. Let's call it as C, whose what coordinates will be 0 comma 25 and radius will be 15. So if this would have been equality, then only circumference point would have been considered, but since this is a less than equals to 15, so you know that all the inner regions of the circle also will be included. Now what is telling us? So basically z is what? Z is all the points which lies on the circle as well as which lies inside the circle. Okay, so now how do we find the maximum and minimum argument? So observe this. If you have a point here, let's say I'm marking here, if you have a point here, you join this. Okay, so this will be the argument. If you have a point here, this will be the argument. So what you are observing that if you move the anti-clockwise direction, your argument is increasing. Your argument is increasing. So see, if you go from point here, 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 here. So if you move ahead, your argument is going to get increasing. So if you observe that there will be one point here, there will be one point here where you will have the minimum argument, and there will be one point here that will be the maximum argument. So what you can say, and see, if you join that point with the origin and this point also with the origin, that will be basically the tangents from the origin to the given circle. Tangents from the origin with the given circles. From this we can establish that these 2 points of tangency will give you the minimum as well as maximum argument. Okay, so now mathematically how do we find that? Let's see mathematically how do we find that. So what am I going to do? I'm going to take this point. I'm going to take this point where will be the point of tangency from the origin. Okay, so and then let's join with the center. Okay, so we know that this angle is 90 degree, and there will be one more. Okay, there will be one more if we join here point of tangency. Let's give the name as, let's say, A and B. So you know that this angle will be equals to this angle, and let's call them alpha. Okay, so argument 1, see, let's say argument of OA. OA will be the minimum argument of Z. OA or argument of OA will be the minimum argument of Z. So if I give the name this point as theta, so minimum argument of Z will be what? Minimum argument of Z will be what? Your theta. Observe this, and from the diagram you can have that as 90 minus alpha. Similarly, if you want to find the maximum, that will be argument of OB, you can write it as maximum of argument of Z, and from the diagram you can see that that is your what? That is your what? This complete angle I'm highlighting here. This is the complete angle, and that will be what? 90 plus alpha. Okay, so basically if you get the alpha, then your job is done, and both the values are actually you can easily find out. See, if this is the alpha, this is 90 degree, so OC will be the hypotenuse. OC will be the hypotenuse, and already you know the value of AC. AC is the radius and OC is the distance from origin to the center. Since C is 0, 25, so OC will be 25. So from here I can directly write sine alpha. Observe this, sine alpha as AC by OC, and simply you will get what? 15 by 25, which will be 3 by 5. So basically you got alpha as sine alpha as 3 by 5, and alpha will be what? Alpha will be what? Sine inverse 3 by 5. So once you got alpha, I guess you get the minimum as well as maximum argument. So your minimum will be what? 90 degree minus sine inverse 3 by 5, and maximum will be 90 degree plus sine inverse 3 by 5. I hope you understood the problem, because this is a very general problem and you should know about this concept. So in a simple way, if in any question it comes find the maximum and minimum argument, then straight away from the origin you draw the tangent, and those point of tangency will give you the minimum and maximum argument. And I highly recommend there is another kind of problem, which is the maximum and minimum modulus, which is that is very common. So I hope you must have solved it. If not, then go and please solve that kind of problem also, where it is asked finding the z or the minimum and maximum modulus of a complex number. Okay, let's move to the next problem. So this is also a very good problem. Observe this very carefully. Okay. So what do we have here? There's a complex number which is satisfies this relation modulus of z minus 2 minus I equals to modulus of z sine of pi by 4 minus argument of z. And we need to find the simplify this relation and tell us what kind of locus does this represent. Okay. So I'm going to assume some things, because he's also not just dealing with z, he's dealing with modulus of z and argument of z. Okay, so let me write as z as x plus iy. Okay, z as x plus iy. So I'm going to write this complex number in the form of polar also, because in the end it will help me to simplify the equation. So in the polar form, if I write, that will be modulus of z cos theta, modulus of z cos theta plus I times of modulus of z sine theta. If you remember this, you can write the same complex number in the Cartesian form as well as in the polar form. So if you compare these two, you should have the relation. You should have the relation x equals to modulus of z cos theta, and your imaginary part y should be equals to modulus of z sine theta. So in the beginning, if you do these annotations to x and y, the problem will be very simplified. So you know how to write this modulus. So I'm opening this modulus. This will be what? This will be under root of x minus 2 whole square y minus 1 whole square. Now observe this, what do you have in the right hand side? So what I'm going to write, modulus of z, let it be like this. Okay, modulus of z. Now what is this sine pi by 4 minus argument of z? So this will be sine of actually pi by 4 minus theta, because if you write modulus of z cos theta and modulus of z sine theta in your polar form, so theta automatically becomes your argument. Okay, so let's open this. Let's open this. What do you have? So you have modulus of z. You know the identity sine a minus b, which will be what? Sine a cos b minus, and then you will have what? Cos a sine b. So observe this very carefully. Very carefully. In this step only, you can figure it out the final answer of this problem. Okay, so sine pi by 4, cos pi by 4, both are 1 by root 2. Now see, what do you have? Mod of z cos theta. Mod of z cos theta, if you observe this carefully in terms of Cartesian, you have simply x. So modulus of that cos theta you can replace with x. Modulus of z times of sine theta you can replace with y. Why did pi by 4 sine and cos go? They both have the same value, and this will be 1 by root 2. So I'm rewriting this equation LHS also. LHS is what? X minus 2 whole square y minus 1 whole square. So to observe this equation and relation very carefully, your answer is here. Okay. So what do you have here? You have under root of x minus 2 whole square plus y minus whole square. This I am putting one value, because the under root term cannot be negative. So x minus y, I am forcibly writing it as modulus of x minus y, and denominator, observe this, you'll have 1 square plus 1 square. So basically, if you if you know your chapters very well, if you know your chapters very well, this is the locus of a conic. Locus of a conic. So distance, observe this very carefully. This is the distance from a point. Distance from a point, and here point is 2 comma 1 is equals to, see, observe this, is equals to, see, there is no coefficient. Generally in this place you'll have the eccentricity, you have the eccentricity, but since it is not there, that eccentricity value is equals to 1, and this term x minus y by under root of 1 square plus 1 square, that is simply the distance from the directrix. So point P, that will be your focus of this conic, and x minus y equals to 0, that will be the directrix. Observe this, there is no coefficient here, so I can assume that eccentricity is 1, and that conic, if eccentricity is equals to 1, that conic has to be what? That conic has to be what? Parabola. So I hope you understood the problem. Let's move to the next problem. Okay, so this is a very good problem, because see, if you have read this problem, okay, read this problem, solve this and come back. Okay, so I recommend pause this problem and then come back. Okay, let's see the solution. Now see, you have this ABC as the integers and not simultaneously have to be equal. So if you recognize this, if you don't recognize this and apply this in the problem, you will definitely get the wrong answer. And believe me, that wrong answer is there in the option. So we will use this at the end of the solution. And what is given to us, omega is the complex cube root of unity, and then the minimum value of a plus b omega plus c omega square. See why this problem is really interesting, because see, generally when they ask for minimum and maximum, they give maximum one variable. Here there are three variables and you need to decide. So why this is a good problem? Because there are three variables. So let's start and try to simplify and by substituting the value of omega and omega square. So you should remember the value of omega and omega square, and omega, you know that is minus 1 plus root 3 I by 2, and then omega square is minus 1 minus root 3 I by 2. So you should substitute so that this becomes a quantity not in complex but in algebraic form. Okay, so what I'm going to do, I'm going to write modulus of a plus b omega plus c omega square by substituting the value of omega and omega square. So let's see what it will give. A plus b times of minus 1 plus root 3 I by 2 plus c times of minus 1 minus root 3 I by 2 whole modulus. Okay, so what we are going to do, we are going to rearrange in the real and imaginary form. So you will have a minus b by 2 minus a c by 2. So this is your real part, and then plus I times of, and see root 3 also you can take common. You will have b minus c whole divided by 2. So you can write the modulus. That will be what? That will be under root of what you will have, a minus b by 2 minus c by 2 whole square plus this will become what, 3 by 4 b minus c whole square. So you need to simplify this term. And get a term from where you can try to deduce that when will be the maximum value. So I recommend you pause the video and simplify this, and you should get at the end a very familiar and very tricky term, which is very important to know. You will get a square plus b square plus c square minus ab minus bc minus ac. So I recommend you pause this and try to get this on your own. Okay, so and you know this term can be easily converted into a perfect square. So what you just need to do, multiply it by 2 and divide it by 2, and then you will have I'm writing it as a perfect square. Okay, so you should know these values. This can be rewritten as half of a minus b whole square, b minus c whole square plus c minus a whole square. Okay, so if you don't know, I recommend multiply this by 2 numerator and see this divided by 2, and then easily you can convert this into a perfect square. So from till here you have the calculation part of the problem where nothing logically you have done. You use your memory where you use the value of the cube root of unity and you simplified it. Okay, from here you need to think about the problem. Okay, so he's telling that the minimum value. Now ABC have to be integers. Okay, so integers, mind it, and there are the perfect square, so negative value is out of the question. Okay, so minimum when it will be when the integers are minimum, the integers are minimum. So what I need to do to reduce the minimum, any two of them I will make it 0, any two of them I will make it 0, but the third one I cannot make it 0, so I will make it minimum possible value, and third one minimum possible I can make it as equals to 1, or even -1 also we can do. But from this combination you can say you have to make any of the two 0 and third one as 1 or -1. So think about it, because there will be no other possibilities, because we are dealing with the integers, we are dealing with the perfect square. The only combination you will have when two of the values of a b c will be 0 and the third one will be 1 or -1 or -1. So if you substitute these values, let's see what you get. You will have half of, see, a is 0, b is 0, so you will have 0 minus 0 whole square, and this will be what, b minus c. You will have 0 minus 1 whole square, and last term will be 1 minus 0 whole square. So in the inside under root term you will have 1 square plus 1 square 2, 2 by 2 you will have 1. So after simplifying you will have only 1 as your final answer. From this you will have option B as your answer. Okay, so I guess we are done with all the 10 good problems. I hope you learned something from this. See, why am I telling you that? Okay, these questions will force you to go through the problem, go through the concepts in a very detailed way, because otherwise there is no way to solve these problems, because these problems uses each and every concept that you have learned in the complex number. Okay, so let's wrap it up and then see you in the next video.